All right, this is the video that goes with lesson 2.5. That's the objectives. Just a few vocabulary words from last lesson. We did talk about domain and range, the x values for domain, and the range is the y values. And I can see that there's an error in this table, which I forgot to correct. It's supposed to say 8, 10, 12, and I'll fix that for the lesson. Guided review, just to remind us how to draw 2x plus 1. So when it's in this slope-intercept form, starting with y equals, the number without the x is going to be your y-intercept. So we can plot that right there. And then the slope here is 2. So that means we can go up 2 and across 1. So when we have this single number, it's always better to put it over x, over 1 like this. And then we can use rise over run to do the counting. And you could complete this process as well. You could do it one more time if you wanted to. And then you can just join it up with a line. Unfortunately, I don't have the technology right now to be able to do that. So we'll just have to do it old school by drawing it in ourselves. As we're thinking about slope, just keep remembering to think about what the difference is between positive and negative, and that can help us to come up with answers as well. So once I saw that last slope was positive 2, I knew my line should be going upwards as I go left to right. Zero slope, an undefined slope is something that people still mix up. So for 0, you can see this is a horizontal line here. That's the H, so that tells you this is 0. And this line here you can see is vertical, and the U helps us to remember that it's undefined. Then there's a warm-up for people to try. And you can pause the video if you'd like to do this. And there should be the answers at the end here that you can click on to check to see how well you did. Let's get into the lesson itself, though. So today, we want to continue finding the line of best fit, which we did last time. But today, we're really going to start making more conclusions based on the data plotted. And we're going to go into a little bit more depth than we did in lesson 2.4. We have several examples here. We're not going to cover all of these in the lesson. As these are all new ones, we're going to try a few out. We're certainly going to be doing these first two, and then we'll probably pick one of the other ones and we'll try them in different lessons to see which ones work the best. So for the purposes of this lesson, I'm just going to do these two here, and that should give you an idea of the type of things that we are doing. So In-N-Out Burger sells cheeseburgers and double patties. So that's when you have the bun, beef patty, cheese, beef patty, cheese. So basically, you have beef patty and cheese 2 times. And while they don't advertise it, they have a secret menu which includes a burger where you can order as many extra beef patties and cheese slices as you like. The prices and nutritional information are not listed though, because as it says up here, it's secret. The most common special order is a 3x3. So that's going to be the bun, 3 burgers, 3 cheese patties, and also the 4x4, which is the same thing: 4 cheeseburgers, 4 cheese patties, etc., etc. However, you can order a 20x20, and there's even 100x100, which I'm not quite sure how you're supposed to eat that, but it has been ordered. So this shows you basically what the double looks like. So you got your basic stuff on here, like your lettuce, your tomato, etc., etc. But you can see here cheese and burger, and obviously a bun on the top and the bottom. So ignoring price, is ordering a double the same as getting 2 cheeseburgers? No, it's not, because if you order 2 cheeseburgers, you would have 2 buns. So this one only has 1 bun, so they're not exactly the same thing. They have the same amount of meat and cheese, but they're not exactly the same. Here's an example of a menu. We can see the double is $4.90, and we can see the regular cheeseburger is $3.50. So we can see that it goes by $1.40. So we know the double is going to be bigger. So as it's just adding on an extra burger, they add on $1.40. I'm assuming it's going to be the same for this one. So I'm going to add on $1.30 to that. And I'm going to put $6.30 for the reasons that I just gave to you. And in our table here, we can see our first few values here. We have $3.50, we have $4.90. We could actually add in our own value that we just set as well. I said it was going to be $6.30. So let me add in $6.30. Oops, that's 5. There we go. And you can see that this is a clearly linear pattern. So like last lesson, we were practicing just finding the line of best fit without creating the data ourselves. So today we're creating the data and finding the line of best fit. So I can see right now this slope is just a little bit less than this one. So I might need to, that actually looks pretty good. That looks parallel to this line right now. And then I know this is the B here. This is the y-intercept. So this moves the graph up. And you can see it's going through this first point, but it's going slightly under these points, which means the slope is not quite steep enough. So let me make it just a little bit bigger. And I think we got the perfect line right there. So the slope is 1.4. The y-intercept is 2.1. So in terms of interpretation, like we were trying to do last lesson, what does this slope represent? So the 1.4 represents for every burger and cheese patty that we add in, the price goes up by $1.40. If we work backwards, basically $2 is how much a burger would be if you had zero patties in. So literally, if you just ordered the bun, they're going to charge you $2. But obviously, that's not really a menu item. But that's the type of thing we've got to be thinking about. And you can see that I did have this here, and you can see that indeed it looks like the 3x3 should be $6.30. And we already answered those questions, but without filling them in. So move to the next slide and use your graph to predict how much the 20x20 would cost. All right, so from here, we have a problem that my number of patties only goes up to 10. So that's not going to be very helpful if I'm trying to find out what it's going to be for 20. So looks like I'm going to need to zoom out for this one. And I can see 20 now, but it looks like I'm in the way for this one. So let me just zoom out one more time. There we go. So on 20, I can actually click on the dot here. Now I'm holding the left mouse down, so I'm not quite at 20. I'm at 19.96, but I can set, oh, I just had it there. 30.1. So that doesn't mean $30.01. That means $30.10. It's just missing the extra zero. Like if I move across here, now you can see 0.38, that would be 38 cents. So when there's only one figure, we've got to be just a little careful as we're reading our answer out. Move to the next slide and use prediction how much 100 by 100 would cost. Okay, so we would have to zoom out quite a bit for this one, but there we go. 100 by 100, $142. Once again, 10 cents, not 1 cent. So how much do you think a 3x3 would cost? And I think we actually answered that one already. That was $6.30. That's actually supposed to ask how much would 100 by 100 cost. So that might be a little typo I need to fix. Now we can do the same thing with calories. We can see the calories of a cheeseburger. We can see the calories of a double-double. So adding in an extra burger patty and an extra cheese slice adds on just under 200 calories here, so 190 calories. So probably if I add on another 190 calories, that should take that up to 860 calories for the reason I just gave. Move to the next slide, make a graph to show how many calories are in 3x3 and use this to predict for a 20x20. All right, so we've got those numbers filled in. We're trying to work on the slope. Once again, I'm just trying to get the slope as close as I can first. That looks pretty good. That looks almost right. So let me move it up. And I got the same problem before. It's not quite steep enough. And actually, I should have known this is not steep enough. Having worked out that it goes up by 190, that rate of change, I only have 180 here. So I can use that to figure out exactly what that should be. And yeah, that looks pretty good. Now, for figuring out the 20x20, I got to do a little zooming out here. And 4,090 looks like the correct answer for this one here. Move to the next slide and predict how many calories in 100 by 100. Well, I could just go backwards, actually. I can just zoom out a little bit more. Go to 100. And then you can figure out the answer from there. Now, I'm actually going to stop the video at this point. I think what I'll do is I'll create a second video for some of the other ones. And then if people want to watch the other ones, rather than watching the whole clip, that might help break this down a little bit for them.